we want to find a moment m that will keep our mechanism in equilibrium whenever an input force of 1200 newtons is applied at point B. And there's two different parts for this problem for different angles of alpha. So we're going to start on part A for alpha is equal to 60 degrees. And to start the problem, we're going to find unknown lengths within our free body diagram. So we're going to start by finding length AE. And this is going to be equal to 100 times the cosine of 60, which is equal to 50 millimeters. And next we're going to find length EB, which is equal to 100 times the sine of 60. And this is equal to 86.6 millimeters. And next we're going to find length BC. And by using Pythagorean's theorem, we can say that length BC is equal to the square root of 400 plus 50 squared plus 86.6 squared. And this is equal to 458.26 millimeters. And next we can find our angle theta in our free body diagram. So angle theta is going to be equal to the tangent inverse of 86.6 divided by 400 plus 50, and this will give us an angle of 10.89 degrees. So next we can take the sum of moments about the point C and set it equal to 0. And this is going to be equal to negative 1200 times the cosine of theta times CD plus force B times CV equal to 0. So we plug in the terms that we know and solve for B, where B is the force at the point B. So we have negative 1200 times the cosine of 10.89 times 700 plus B times 458.25 equal to 0. And we solve for B, which will give us a force of 1800 newtons. So we can now solve for the moment. So first we say that the sum of moments about the point A is equal to 0. And we can write that as negative B times the sine of theta plus 90 minus alpha times BA plus M is equal to 0. And after plugging in, we get 1800, negative 1800 times the sine of angle theta plus 90 minus angle alpha times BA plus M is equal to 0. And solving for M, we get a moment of 117.8 Newton meters. And this completes part A. And now for part B, we're given an angle alpha that is equal to 90 degrees. And we solve this problem in a similar fashion. So we start by finding our unknowns, our unknown lengths. So length BC, that's going to be equal to the square root. So Pythagorean's theorem is going to be the square root of 400 squared plus 100 squared. And this gives us a length of 412.31 millimeters. And solving for theta, the angle theta in the free body diagram, this is equal to the tangent inverse of 100 over 400, which is equal to 14.036 degrees. And we now take the sum of moments about a point C, set it equal to 0, and we can write this as negative 1200 times the cosine of theta times CD plus the force B times CV, and set it equal to 0. So we plug in terms and solve for B, and this will give us negative 1200 times the cosine of 14.036 times 700 plus B times 412.31 equal to 0. And solving for B, we get a force B that is equal to 1976.5 newtons. And now lastly, we can write that the sum of moments about a point A is equal to 0, which we can also write as negative B times the sine of 14.036 times 100 plus M is equal to 0. So we plug in B, and that will give us negative 1976.5 times the sine of 14.036 times 100 plus M is equal to 0. And solving for M, we get a value of M that is equal to 47.94 Newton meters. And that completes part B.